What's up y'all, it's me Jaren Lim, your Indonesian mental health advocate. Buat neurodialecticers yang orang Indo, jangan lupa kalau semua video gue itu subtitlenya tersedia dalam dua bahasa. Ada bahasa Inggris sama bahasa Indonesia. Jangan lupa dinyalainnya kalau butuh. A few days ago, I saw a very interesting post on Subtle Asian Mental Health. In short, this person said that they were extremely suicidal after taking Zoloft or sertraline, which is an SSRI, and that they were even hospitalized afterwards. However, they are no longer suicidal now. They were wondering if the suicidal ideation could be due to the sertraline. If yes, how could an antidepressant that was supposed to alleviate depression causes depression instead? Let's take a step back. In the previous video, we talked about a few hypotheses that contributed to depression. In one of the previous videos, I talked about the glucocorticoid hypothesis. I mentioned that an increase in cortisol and a decrease in the number of glucocorticoid receptor is related to the development of depression. In another video, we also talked about the neurotrophic hypothesis. I mentioned that a decrease in BDNF, or brain-derived neurotrophic factor, is related to atrophy and the decrease in the survival rate of our nervous system, which makes us more vulnerable to depression. In this video, I want to talk about the monoamine hypothesis. Monoamines refer to a particular group of neurotransmitters. Neurotransmitters, on the other hand, are chemical messengers that transmit a signal from a neuron to the target cell. Monoamines include catecholamine and indolamines. Catecholamine includes dopamine, norepinephrine or noradrenaline, and epinephrine or adrenaline. Indolamine, on the other hand, includes serotonin. Monoamine hypothesis basically posits that mood or affective disorders such as depression and anxiety are related with the dysregulation of these neurotransmitters. Let's take a look at how neurotransmitters work. If you think about our neurotransmitters, it is actually pretty similar to our mobile phone signaling system. Waves are sent from the caller to the callee via receiver tower. The caller depicts the presynaptic neuron, while the receiver tower portrays the postsynaptic receptor. The neurotransmitter, on the other hand, are like waves, and the receiving neuron, or the postsynaptic neuron, is like the callee. The structure where the presynaptic neuron and postsynaptic neuron meets is called the synapse. Let's use serotonin as an example. If we zoom in at the synapse, this is what it looks like. The L-tryptophan, an amino acid we consume from food, will be transported into the presynaptic terminal. In our neuron, we have an enzyme called L-tryptophan hydroxylase, which will convert our L-tryptophan to 5-HTP or 5-hydroxytryptophan. And finally, 5-HTP will be converted into serotonin by the AADC, or aromatic amino acid decarboxylase, which is also an enzyme. These neurotransmitter molecules will be packaged into the vesicles before it's transported into the synapse and then postsynaptic neuron. Before these neurotransmitter molecules enter the vesicles, they need to go through VMAT2, or vesicular monoamine transporter 2. Think about our vesicles as cargoes, while our VMAT2, our transporter, is like the door. These doors will sort out monoamine molecules from non-monoamine molecules. Therefore, only monoamine molecules, such as, for example, serotonin, can enter these cargoes or vesicles. These vesicles then transport and release the neurotransmitters that were packaged into this vesicle previously to the cleft between the presynaptic neuron and the postsynaptic neuron, and this cleft is called synaptic cleft. This mechanism of release is also known as quantal release. After those serotonin molecules are released into the synaptic cleft, they will find and bind to the postsynaptic serotonin receptors, and these receptors will start the signaling cascade, which will eventually elicit certain physiological responses in our bodies. Until now, there are at least 15 different types of serotonin receptors that have been found, and all of them pretty much serve different function and yield different physiological responses. For example, binding of serotonin molecules to the 5-HT2A receptors will cause an increase in impulsive behavior. On the other hand, binding of serotonin molecules to the 5-HT2C receptor will cause a decrease in impulsive behaviors instead. Now, talking about the mechanism, one of the most important paradigms in neurotransmitter regulation is homeostasis. Remember, homeostasis is any self-regulating process by which biological system tends to maintain stability. We don't want our serotonin to be too much or too little in our body. That's why we have this process. When we have a super high level of serotonin in our body, we have at least 3 mechanisms that have been discovered to get rid of the serotonin molecules. The first mechanism is through metabolism. There are 3 main enzymes that are responsible for monoamine breakdown. The first enzyme is COMT, or catechol orthomethyltransferase enzyme. This enzyme is known to be responsible for the degradation of catecholamine molecules, namely dopamine, norepinephrine, and epinephrine. The second enzyme is MAOA enzyme, or monoamine oxidase A enzyme. I talked about this enzyme a little bit in my first video. This enzyme is primarily responsible for the breakdown of norepinephrine and serotonin in our body. And lastly, MAOB enzyme, or monoamine oxidase B enzyme, is mainly responsible for the breakdown of dopamine. Let me give you an example. Serotonin molecules will be broken down into a metabolite, or the byproduct. And this byproduct is also known as 5-HIAA, or 5-hydroxyindoleacetic acid. This metabolite eventually will be excreted in our urine. And by the way, this is why our neurotransmitters are transported in the vesicles. Storage of neurotransmitters in vesicles plays a very critical role in protecting these molecules from enzymatic breakdown in the terminal. And the second mechanism is via transporter. We have SERT, or serotonin transporter, on the surface of our presynaptic terminal. We also talked about this a little bit in some of my previous videos. SERT is responsible for reuptaking molecules, in this case serotonin molecules. In other words, when there's a very high level of serotonin in the synaptic cleft, they will move back to the terminal and either be reused or be broken down by the enzymes I mentioned before. And the last known mechanism is through autoreceptor. One of the examples of serotonin autoreceptor is presynaptic 5-HT autoreceptor. This autoreceptor has an inhibitory effect, meaning it causes signaling cascade that tells the presynaptic neuron, hey, we have too much serotonin molecules right now in the synaptic cleft. Slow down. Then the rate of vesicular formation will decrease, and as a result, serotonin release will also decrease. Already, let's go back to our main question. Why do some people feel suicidal after taking some SSRIs, such as sertraline or Prozac? Remember, one of the possible mechanisms of the development of depression is due to low level of monoamine, such as serotonin level in our midbrain or mesencephalon. SSRI, such as sertraline or Zoloft, and fluoxetine or Prozac, bind to the SERT on the surface of our presynaptic terminal. These drugs inhibit the reuptake of serotonin molecules from the synapse into this presynaptic terminal. As a result, serotonin molecules cannot go back to the presynaptic terminal. They will float around in the synaptic cleft. So we have an elevated level of serotonin level in our synaptic cleft that binds to the postsynaptic receptor. Ideally, we would expect that depression would alleviate at this rate. However, remember that we have the third mechanism. Also remember the first paradigm I told you. Our bodies are always trying to reach the homeostasis. As our serotonin bioavailability increases in our synaptic cleft, binding of these molecules to the autoreceptor also increases. Our autoreceptors will then send a signal to our presynaptic neuron, telling them, hey dude, slow down, we have too much serotonin level in our presynaptic cleft right now. Stop it, stop it. This is because we have an abnormally perceived higher level of serotonin level compared to baseline. And remember that the baseline level of serotonin level in depressed patients may be much lower than non-depressed people. Therefore, just a slight increase in serotonin level to a supposedly the normal range due to the SSRI intake can cause their body to think that they need an adjustment, and their body will naturally want to gain homeostasis. That is, by decreasing serotonin level significantly. That is, by decreasing serotonin quantal release, by decreasing vesicular formation. Therefore, because of the negative feedback to our presynaptic neuron from our autoreceptor, our serotonin level in our synapse will decrease dramatically to even lower than before. And within this period, people may feel extremely depressed and even suicidal. However, within 2 to 3 weeks, that is when the magic happens. Our body is amazing. Remember that we also have the allostasis mechanism. Allostasis is defined as the process of maintaining homeostasis through the adaptive change of the organism's internal environment to meet the perceived and the anticipated demand. And at this point, our body will realize that there's an abnormally significant decrease in the serotonin level in our synapse. And consequently, these autoreceptors will be downregulated, meaning they will be inactivated and be reabsorbed to the presynaptic terminal. As a result, negative feedback will also decrease. And as a result, serotonin release will increase again to a level that is even higher than before. It takes around 3 to 6 weeks for most people to feel the full effect of SSRI. At this point, this is when the meds kick in, I would say. Most patients will feel much less depressed, less suicidal, less anxious at this point. And also, that is why it is recommended for most patients to take antidepressants for at least 6 months. This is because we want these meds to affect our epigenetic expression permanently. And when it happens, our body can set a new baseline via the allostatic changes. Some people may need to take antidepressants for their whole life. Note that this is only one of the possible mechanisms. There are many possible explanations. When the dose of the med is too high or inaccurate, it may induce suicidal ideation. That's why, even though antidepressants are generally extremely safe, it is also extremely important to be supervised by a healthcare professional. Meds are like a knife. When they're used correctly, it's safe and it is beneficial for you. But when you use it unwisely, they may harm you. In general, rule of thumb, when you take antidepressants such as SSRI, it is recommended to start from a very low dose before reaching the maintenance dose. For example, even though the maintenance dose of sertraline for MDD in adult is 50 milligram and the maximum dose is 200 milligram, healthcare professionals usually start the patients from 25 milligram or 50 milligram. They will not jump to 200 milligram right away because it can cause suicidal ideation in those patients. It usually takes weeks before healthcare professionals start to increase the dose to the desired range. They will increase until you feel better. But if increasing the dose to a really high dose or a maximum dose does not make you feel better, that's when they will add another med or change you with another med. And lastly, remember that environmental factors are not less important than biological factors. They're not negligible. Even if you are routinely taking meds and you see psychologists or therapists routinely, you can still have the depressive episode in your life. You can still be vulnerable when your environment is not supportive. And finally, from this video, I really hope that you can recognize, you can be familiar with the meds you're taking more instead of being afraid of taking meds. Because healthcare professionals are trained, they know what happened. So if you feel suicidal, for example, after taking some meds, just tell them, be honest with them. They can adjust the dose, they can switch you to another antidepressants that are more suitable for you, for example, or they can add more meds for you. So don't worry about taking meds. You're on the right track. You're doing a really good job. And if you feel stressed every day, you feel your mental health impairs your performance in your daily life, don't forget, seek professional help right away. Remember that mental illnesses do not differ from physical disorders. They need to be treated. I hope you enjoyed this video. If you like this video, please like, share, and subscribe. And follow my Instagram right here. See you in the next video.